So we have a topic here, Ohm's law. So according to Ohm's law, it states that the current flowing through a metallic conductor is directly proportional to the potential difference across its end, provided that the physical condition of the material are kept constant. Now those physical conditions they are what? Number one, we have resistance. We have resistance. Number two, we have the length. We have the length. What we call the cross sectional area. Cross sectional area. And we also have what we call temperature. The temperature. So the constant material and in Ohm's law. So according to Ohm's now, so we're going to be deriving the equation for for these three physical constants. That will give us the resistance is going to be directly to the length. Equation 1. What if we have resistance as varies directly to varies inversely to cross-sectional area, which is equation 2. Now mathematically, we're going to apply what we call joint variation on this. To give us our resistance here, equally one resistance. You have varies. Then this length times this one will give us L over area. Equation 3. Now in this case now, we're going to be expressing what this varies. The varies is going to be, let's go to the other side of the board. That will give us varies, resistance. Varies is going to be equals to K. Then we have times L over A. But this K is going to be our constant. And in resistance, constant is represented with what we call resistivities. That means that we're going to take our K equals to P. We call it We call it rho, right? So we're going to be having resistivities. Resistance equals to resistivities times L over K. So your resistance equals to PL over over the cross-sectional area. Now you can only use formula for any question that involve resistivities, length, and area to solve for resistance. And if you have to find for resistivities, it means that you are going to make these resistivities the subject of the formula. So by you cross multiply in this place to give resistivities times length equals to resistance times area. So give us, you have to equate this length over the length, this cancel out. So it means that resistivities equals to resistance times area over length. Now apply formula for, if you're looking for resistivities, you're going to use formula for it, right? But in the sense that we're not giving radius, whereby there's no area. So if you are giving radius, it means that you're going to take note that your area equals to pi r square. When your area is pi r square, it means you're going to take the resistivities equals to resistance times pi r square, which is for area, over the length, which will give us resistance pi r square over length. Now, why in some other case they will give you diameter instead of them giving you area, they can give you diameter. Just note that mathematically, diameter is equals to 2 radius. 1 radius is equals to diameter over 2. If you are giving diameter instead of radius, note that diameter is 2 radius. 1 radius is diameter over 2. So it means that we're going to replace the radius that is here with with diameter over 2. Because Because we are giving diameter, not radius. So we're going to be having resistivities equals to, we have resistance times pi r square over the length. So therefore, we're going to have resistivities equals to resistance pi, what's our radius now? That change to d over 2. We have d over 2. Then r square. Then over the length, which will give us resistivity equals to resistance pi times. Now when we have d over 2 all square, it means that multiply this d in two places, in two places. That will give us g times d over 2 times 2, and all over the length. We have resistivity equals to resistance pi times this time. This will give us d square. What's going to give us 4, then all over L. Now breaking more further, we are going to be having resistivity equals to resistance times pi, then times d square over 4. This one change to divided by 1, divided by by L, right? To balance the equation more, we're going to put over 1 here, right? So it means that we're going to be having resistivities equals to resistance. Let me make it as pi r, pi resistance times d square over 4. Now flip this one now. This divided into times. That will be times 1 over what? Over L. I took this one up, I bring this L down. This divided into what? Divided into times. So we're going to be having final formula as resistivity is equals to per d square r over what? 4L. That's for formula for what? For resistivities. So it means that I break what the whole formula under this Ohm's law down. Okay, so don't forget to like my video, share and comment. Thank you.